So I'm Ronny, CTO of Next, and I want to share with you the journey we went through to adapt generative AI to make more sense out of data. So what I want to do with you is the following. I want to give you a bit of an idea, the kind of data and the kind of users we're having, so you can see how that applies to your context. And then I want to take you literally through the journey that we took to build our dashboard. So let's get started. What we do as a company. Just one slide, but I think it's important to have a bit of background. So that's the fundamental problem that we're trying to solve is the following, that half of the things we're building as product teams are waste, right? So they have no impact on customer satisfaction. They don't drive sales. And if you think about it for a company, that's pretty, a lot of waste. But I think also as a developer or designer, you might be a bit frustrated that you could have the same impact by working 2-3 days per week. So I think that's a problem worth solving. And you might know a couple of these approaches, how we can bring this percentage down. And the most traditional ones is UX research. And just let me very quickly run through this. So typically in UX research, you have a research question. So for example, Spotify, they might ask themselves, what was the biggest hurdle using the Spotify app? Then they do a couple of user interviews. Then the UX researcher takes these calls, transcribes them, highlights the bits and pieces that are the most interesting about it, puts them on some Post-its, puts them on the wall, converges them, creates ideas out of this, and so on and so forth. In the end, it goes all into a report, which gets then handed over to the product manager, that then translates into some work items for the teams that are supposed to do something about it, right? And so what we focus on is this one step here from the videos to the highlights. And where before the UX researcher, typically it takes them 2-3 hours to process something like this. Now we can do this in less than a minute. Now, of course, the first reaction is, oh, that's really cool. It goes much faster. And the second reaction is, hey, why don't we just do way more of this? Now you will see that, of course, making more user interviews is quite difficult because you need to have somebody that you can interview and somebody has to do the interviews. But if you go a step back and you look at what other interactions do we have with our users, there's actually way more, right? So for example, your customers, they might be calling you and telling you, I have a problem with that thing. Or your account managers might be talking to your customers and they learn things about the product. And the salespeople are reaching out to leads, might learn about the product, pricing, and so on and so forth. So what we're getting now to is we have way more calls, which means we can process them quickly. So where we had maybe before our 5 calls, 100 Post-its, now we have, 500 calls and 10,000 Post-its. But it has actually more implications. So one thing is if the UX started with a question. Now, the people who call you on support, they don't care what you're researching. They just tell you this thing doesn't work, which means we can get rid of the question. And if we get rid of the question, we can also get rid of the report. And if we get rid of these two things, we can actually reverse the whole thing. We don't need anyone to pre-chew the data, but we can enable people in the product team to query this repository and validate stuff. So that might be the PM checking what are people talking about. It might be developer who has a ticket, wants to see is it actually real or people just make it up. Or designer who just has information people are struggling, but then wants to understand more in depth. Or the marketing team wants to know how the new pricing model lands. Okay, and so that's kind of where our journey started around the dashboards. And I just want to highlight one thing here. So we have on the one side, we have now quite a diverse set of users, right? Before we would have only UX researchers who were in these interviews who knew the data. So now we have PMs, developers, designers, marketing people who don't have a clue about what this data actually contains. And on the other side, we don't have any longer, 100 Post-its that we can put on the wall and let a human read through. But, we have 10,000, 100,000 of these data points. And so what do we do when we have a lot of data? Well, we create dashboards. Okay, so empty dashboard. So then the question is, what do we put on a dashboard? Now, the first step was, of course, very easy. We say, hey, time we have. We know when these things are created. We can plot this out so you know how fresh your data is. And then it got interesting because then we thought, what's the other thing we actually have? And we realized there isn't much, right? So we know where these calls come from, but honestly, if that comes from Zoom or from Teams, doesn't really make much of a difference. And beyond this, there wasn't much. But if we looked into the data, we realized there is actually more structure. So here's a 3 examples from Spotify. So the first one is, people, they value the offline song downloads in Spotify Premium. The second one is people are frustrated about missing album art. And the third one, that they ask for more language options. Now, if you give this to a user and a human, and you ask the human, okay, do they have something Are they somehow different? Then a human will tell you, sure. The first one is positive feedback, people that love the offline support. And there's a product issue that the album art is missing. And there's a feature request that we want to have more languages. Now, the question was, how do we get this from the text that we have there in these video clips into the structured format? Now, you know, the standard answer for this is build a classifier, and that's what we tried to do. And that failed pretty miserably. And the reason why it failed was, first of all, we don't have that much data at the end of the day for individual teams. So, you know, might have a couple of thousand, maybe 10,000, but it's actually not that much data as a training set. Then asking our users to label this manually didn't really work out. And then we run into the final issues, which is we work a lot for corporates, companies like, I don't know, Bosch, Erste, Deloitte, those kind of companies. So if you go there and tell them, hey, we want to train a model for you, it always goes like, wait a minute. And if you tell them, well, we want to train the model and then we want to use it also for other customers, well, if they're polite, they just say no. So this wasn't going to work out. So then we went back and we thought, what can we do? What's actually the real problem here? And what we realized is that this is, you try to understand like a human would understand. And that's the kind of stuff LLMs happen to be really good at. So what we ended up is doing something like this. So it's font, means always, it's kind of a prompt. So the prompt that we're using for this is, we give it a bunch of the highlights, so like our post-its. And then we ask it, can you classify them for us? And here's the categories we have for you. So is it a feature request? We describe what the feature request is, or product issue, or positive feedback item, right? And then this works actually really, really well. So then you might not be able to see this, but there is now labels here where you can see the different categories. And so if we look to the error rates, it's actually pretty precise how that works. Now, if you want to do this yourself, there's a couple of points we learned that I would like to share. So the first one is have an others category. Otherwise, the LLMs, they tend to just squeeze your data into what's the closest to it, even though it's not really close. So having the exit route is certainly a good thing. Another thing is, so we're asking here for, as a response, a JSON array with the highlight ID in the category. And it's literally how we started the whole thing. And what it then returned was something like this. So you see there is, highlight, category, highlight, category. And, if you would, this would be an API, this would be, good design, right? You can see what it is. It's easy for a human to understand. And we don't care about it. There's a lot of repetition because it gets compressed anyways along the way. Now with LMs, that's not the case. So it really reproduces them over and over, and you pay for it over and over. And you pay for it not only in money, but also in processing speed. So you really want to have a look here for the tokens. And you're particularly interested in the output tokens since they are around, with OpenAI, 3 times as expensive than the input tokens. So I really want to optimize that. So the first thing that we saw was, well, we don't really need these fields here, right? So we port it down to a map. So on the left side, you have the IDs of the highlights. On the right side, you have the categories. Now, if you look further, then you see, well, we only have a handful of these categories. So we don't really need it to spell out that it's a feature request. If you give us back a F, we also know that this is a feature request. And then we look to the IDs. And so the IDs, these UUIDs, they allow you to express, billions of different things. But due to the token limits in the LLMs, you never put more than a couple of hundred highlights into a request anyway. So there's no point of having this enormously long IDs. So what we did now is we just create like a counter. We say, well, first one, second one, and so on and so forth. So when we send it to the LLMs, we translate it from our internal IDs into the short IDs. And when we get it back, we translate it back. Now, a word of caution here. Some people might remember their computer science classes, what you can all do with compression and so on and so forth. So don't overdo it. So, with the numbers, you can have now 10 different states with 1 character. If you would use letters, you would have 26, and you could, of course, go even further than this. But at one point, the LLMs will get confused, right? So then you might think it's no longer really an ID, it's something else, and it will start to do weird stuff. The other thing what you could do here as well is you actually also don't need a map, right? You could also just use an array because you know what's the first and what's the second. Now, we opted in the end against this because the LLMs sometimes return weird things, and it helps a lot with error handling, what we're doing here. So, for example, you might pass, 500 highlights, and it returns you 501 responses. How do you know what is the one thing that you need to take out? So we found this format works for us pretty well to detect these errors and then handle these errors. Good, so that's the token sizes. So with this, we have now a second chart on our dashboard, right? So we see now here a breakdown of the highlights by their type, which is good. People get the feeling of what the data is about. But one problem is still there. If you would have 10,000 highlights, 30% is still 3,000. We can't really plot this and ask a human to read through them. So we needed to aggregate the stuff further down. Now, summarization is, of course, one of the things the LLMs are really, really good in. So what we did is the following. So we created these clusters, and we give a prompt along those lines. So we provide it with a list here of feature requests, and then we ask it to identify recurring themes. And then we ask it to return us the clusters with these titles and descriptions. And we say, please make sure that they actually bit diverse. And that leads us then to a cluster, something like this, which is, so it says that people, they appreciate the music discovery features, and it points out recommendations, genre-based playlists, and so on and so forth. So we're getting more into a world where it's compact enough that you could ask a human to manually look through this, these responses. Now, we, of course, have still one problem here. So far, we only know what the boxes are. We still don't know what's actually in them. So the link is missing. Now here we can, of course, use again our classification that we saw before. And I think now you also see how this actually shines more here. Whereas with the types, we still had static categories in which you wanted to put them. So you could still think how you could train a model for that. So here we are now way more dynamic, right? So we somehow get these clusters. They can change all the time. All the time we can just inject them in the prompts, and we say, these are the categories you should classify it on now, right? And then it says something like classified each feature request, and then we have the different classes for that. Okay, also a couple of tips for this one if you try this out. One thing that helped a lot of improving the quality is to look into more homogeneous input data. So initially we just, we dropped all the highlights there. We said, somehow create a couple of classes for us. And that went a bit all over the place because you would have feature requests, pain points, positive feedback, and it made up connections weren't really there. So then what we started to do is we used the pre-classification that we had, and we give it, for example, only feature requests, and we ask, give us only classes about feature requests. And then we do the same thing for example, positive feedback, and we create classes only for this. So this improved quality quite dramatically. Another thing to keep in mind is you might want to have these clusters comparable if you want to show them afterwards. So for example, if you look into product issues, you don't want to end up in a situation where one is the red button on the lower side should be 5 pixels to the right, and the other one, the UX is totally garbage, right? Because these two things are not really comparable. So what worked for us pretty well is working with examples. So we would say, okay, here's 3 things of the granularity that we are looking for. And then you also tend to get more consistent returns. Similar thing for the format instructions. So for example, for some of them, we want to have this like Scrum story format as I want this and this for that and that reason. So if you give these formats, it's pretty good of returning then also a more consistent titles and descriptions back. And the last one, so this comes back to the ID optimization I talked about before. Now here we are one step further, right? Because here we don't have only one type of IDs, but 2 types of IDs. And here you need to be a bit careful. If the IDs are too similar, we often saw that the LLMs got confused about and mixed these 2 entities up. So what we ended up with, we have one IDs, they start count at 1, the other one at 1,000, and it helped us to keep these 2 things separated. Good, so that brings us to the cluster. So we have now one other thing filled in our dashboard. We have now here below the section of the clusters that a user can look through. Now, when we had the dashboard at that stage, especially the PMs still loved it, the developers, they also really loved it. But then we figured out there's actually also users that don't really think in numbers and graphs and so on and so forth. And without going too much into cliche, but the more I speak to designers and some UX researchers, people will go back and say, yeah, it's colorful, that's nice, but what I'm supposed to see in this thing here? Why don't you just tell me what I'm supposed to see here? And therefore, that's actually an interesting idea, right? So we have all the data. Can't we use somehow generative AI to come up with a description, what you see in the dashboard and what you should do about it? And so we went for a couple of iterations of this, and let me just share them with you. So the first thing we did is, the simple idea, let's just summarize it. And so we used the prompt along those lines of, summarize the following, and then we were writing out what's in the dashboard. So for example, that's the number of highlights we have here. It's the ratio of the user panes. This is the biggest class, it's the fastest growing ones, and so on and so forth. And then we ask it to create a summary that reads more like a newsletter type of thing. And when we released it, people really liked it. But then, talking to people a couple of weeks later, people were a little bit less excited about it. And the main problem was that the data actually didn't really change that much, which meant that the text stayed the same. And people say, yeah, it's great for onboarding. But once I figure out what these charts and numbers are about, well, basically you just waste a third of my screen with telling me the same thing that's already in the charts, and every week it's the same. So we thought, okay, let's make it more, recent. Let's build what's new. So the way we did this one is we used the same summarization I just showed you before, but we cut it off the week before the last. And then we gave the new data and we asked it, can you compare it to the old summary? So, point out what's new and point out what was reinforced. And then we provided also a couple of trends. Like you can see here, the number of highlights increased, the ratio of user panes increased from 20% to 35%, this kind of input. And then it created this what's new section. And this what's new section, it worked, but in a way it worked too well. Because what would happen is, so if you go back to the Spotify example, typically in Spotify, everybody's complaining about the ads. It's the number one thing there. So you might have this thing, but then suddenly, there's an outage, and people only talk about that. Now, if you think what what's new should do, that's exactly what it should do. Suddenly, that's what it's all about. But what the user said, that's not how they think about it, because they're having these dashboards to track something. And so every week, they're just looking there, to see the same thing. And if the topic is just jumping wildly around, from ads to outage to billing to this and that, they find it confusing. So then we went back and forth if users know what they are looking for, why don't we just ask them for this and give them the answer? And that's what we're doing nowadays. So the user, they can provide us with a user question. And then we have a prompt where we say, we give you the data to the LLM, please answer this user question. And make sure you have it based on the data we provide you, obviously. So, and that kind of finishes the dashboard that we have today. So you can see now on top, the user can enter the question they want to have answered, and then on the right side we show a text representation of the answer to their question, right? And that's kind of the way how they're pulled into the dashboard and are then invited, to dive deeper, and then they can filter in it and so on and so forth. So standard dashboard behavior if you want. Good. Well, as said, that's the dashboard we have today. So let me maybe start to wrap this up here. So there's a couple of things I would like you to take with you. So when we think about GenAI, I think we think a lot about summarization use cases or generative use cases. But I would suggest that also for classification, it can be a really good tool. Obviously, not for every use case, but it can be a good tool in your toolbox, particularly if you have smaller, unstructured data sets. The other thing is, look if you can go beyond what you have today, right? So for example, a lot of the dashboards and data things we're doing, they're hard to access for non-experts. GenAI can be a way of translating it into normal human speak. So just have a look if there's opportunities to make your data more accessible. And the last one, I think I touched on this a couple of times. Think about your token usage. Sometimes you get very carried away that all these cool things AI can do, but then sometimes you just go back on the standards we had for making data efficient, make compute efficient, and there's a lot of these best practices you can actually apply there. Good. That was the things I wanted to share. I stayed away from any product pitches and the like. If you're still interested what our product does, beyond the small thing I showed you today, it's a link to our website. There's also a sign up so you can try it out yourself and you can see what it does. I think we still should have a bit of time for some questions. So if there's any questions, happy to take them.
Hello, welcome. Please find a seat. Today we're gonna tell you a little about TenderFlow. So a few steps back, Vincent, Bas, and me started working on an app challenge. This app challenge was provided by the Open State Foundation. Tim will talk a little bit more about this. And this app challenge we won, and we could develop a GenAI app for them. So Tenderflow, the idea is that it brings government tenders or procurement within reach, and we will show you all about it. So the idea is that Tim will provide you some more information about the Open State Foundation, so the agency that provided this assignment for us, and about the Buitenlandse Zaken. Binnenlandse. Then we will demo our app, and I will tell you a little bit more about how we use RAG and what things we saw there. And I take you along our journey about why RAG is hard. And we'll show you some learnings that we faced during our process. But first, Tim.
Thank you, Martijn. Thank you all for having us. Thank you, Xomnia, for having us. Open State Foundation and the Ministry of Interior Affairs, not Foreign Affairs, asked the question, how can we bring procurement data, tenders, within the reach of more businesses? How can we enable more people to use this data? Because Open State is a non-profit, we are a group of people who investigate, we hack data, and we develop tools on a variety of issues, but all related to public spending, public administration, governments in general. And to get to the point, our mission on public procurement is we want it to be transparent. We want it to be available as open data, because we know you can use innovative technologies to use this data for your own benefits, for the benefit of our society. And in the end, it's all about making money, using data, letting data flow. Therefore, I really liked the name Tenderflow, because it's also about data flowing. The challenge we set out with was one of access to data. Procurement in the Netherlands is subject to a lot of laws, rules, regulations. If you want to participate in a tender, you have to read a lot of documents. You have to hire a lawyer to help you understand every rule. And for large corporations, it can be up to 50,000 euros just to enter into a bid without any security that you'll win. You can understand that small startups, small companies are deterred to participate. And our Dutch government, the Ministry of the Interior, also realized that having only one or two businesses enter into a bid wasn't the way to reach the best results, to reach the cheapest results, the cheapest products, or the best products, or optimally a combination of the both. Open State Foundation failed in its mission. I'm saying this is a bit harsh. We failed moderately. We failed at failing. We did improve procurement data publications. So there is more data available than since we started with this project about 4 years ago. But the data still continues to be of poor quality. Sometimes because of really human reasons, because some procurement officer thinks the amount of the bid is confidential. So they enter 0 or 1 euro. There are a lot of bids in the system that are 1 euro. And actually there are millions of euros. To give you a perspective of how much money we're talking about, it's $16 billion every year. Data is often not publicized as open data. It's a lot of PDFs or web forms. And we were not getting there by advocacy. We were not getting through to the people in charge, only moderately. We were thinking about using innovative technologies, but working with governments means you have to have another kind of standards about using AI. There are a lot of concerns. Economic securities. Are we using applications based in the EU, or are they based in America? Are we sending our data over to America, which is potentially could have implications for state security? You can imagine that you don't want to send your defense contracts over to China or to India. No offense intended. Large language models, the big ones, are all trained on enormous amounts of data. I don't have to tell you that. But is that data ethically harvested? We have questions about that. The government has questions about it. And if the hammer is bloody, can you still use it to hammer in the nail? Or are you ethically wrong to do so? And then there is the concern about disinformation and misinformation. Disinformation, for those who don't know the difference, disinformation is the act of actively trying to misinform the public, trying to create fake news, for example. Misinformation isn't malign. It's unintentional. It's getting information wrong. And that has to do with the knowledge gap. And I want you all to do an experiment with me. We don't have a throw microphone, so we'll do it in pairs. You can talk to your neighbors on your row. I would like you to get your phone out. I'm guessing most of you have an AI tool, a chatbot on your phone. And it's called the Henk Krol misinformation experiment. Henk Krol is a Dutch politician. Oh, I didn't set it right. So the challenge is ask your preferred AI chat tool to generate a summary of the CV of Dutch politician Henk Krol. Try using that prompt, and I'll give you 2 minutes and discuss with your neighbors if the result is correct. Try to find out if the result is correct. If you don't have it here, you can do it at home. Right, you know what? I'm not going to be silent for 2 minutes. I see a lot of you have taken out their phones and been asking the question, and you get a result. And if the temperature is set right, those results will differ from your neighbor a little bit. The point of this experiment is you have to be a domain expert at Henk Krol to know if the answer is right. There is no intent of the chat tool to give you the wrong information. But most users of AI are not techies like yourself. They don't know what AI is. They don't know what a large language model does and what the risks are and what you should check and what you shouldn't check. So misinformation getting into the world has gotten a lot closer because of AI, because people don't recognize it. You sometimes even have to have a PhD to recognize something is wrong about an answer. Now, how many people do have a PhD? Probably a few in this room. I see some hands. Enter AI. Perhaps few people know this quote. It's from Hamlet. It weighs me still, go on, I'll follow thee. It's about the ghosts, trusting in something you can't really see or understand, but you do trust it, you do follow it. But in doing business with the governments, we can still do pilots, we can do experiments, and we can manage risk. And that's why we fully support Tenderflow as the winner of our app challenge. And we will probably be doing business for the few coming years. At least that's our intent. So please give it up for Martijn so he can talk about Tenderflow.
So thank you, Tim, for the nice introduction and a bit of an idea what the government is struggling with. But maybe back to the definition of a tender. So we have a procurement contract for the government, and there are certain rules for that for businesses to apply for. So what kind of data is then so hard to reach, and how is that problematic? So this is an example of a tender. It contains 18 documents, and all of these documents have more than 30 pages. And you can see how big this problem is for a small or medium-sized company applying for this tender with a contract value of maybe 100K. Then you already lose 50K for the applying. Also, there are a lot of legal issues with tender, so you need to be an expert. And like the previous example, those businesses do not have this legal person on board. And lastly, it is just very hard to read. When I want to apply for a contract that does the cleaning at a municipality, I will not use this to apply for it. So, this jungle of information creates an unequal playground, and I think it harms the innovation. So, with Tenderflow, we have tried to help this, and I want to give you a little demo. So this is a chatbot, and with Tenderflow you can chat with your tenders, and you can ask it very specific questions about these tenders. So say you're a small company and you want to know if your company is certified to apply for this tender, for example. So Tenderflow has two components. So you can chat with information about more the tender process, and you can chat with the specific tenders themselves. So it's currently live. It's at tenderflow.eu. You can look it up yourself. But Tenderflow provides an overview of all tenders listed on TenderNet. So this is the company that lists all of these tenders. And we will look at an example of the car fleet management tender of the municipality of Haarlem. So this is a specific tender that looks for someone that manages the fleet of cars. And as you can see, it is publicated on TenderNet. And there are a lot of documents in this tender that you need to go through to apply for this tender. So you can imagine how much time this takes. So the idea of Tenderflow is that you have an easy interface to this tender and can ask questions about these specific documents. So for now, we have selected all of these documents that should be included as a context within our system. And an LLM-based model will answer your question based on the context of this tender. And so indeed, what Tim was saying, how can you check this information? We now have this information within our reach. So as an example, the example is, should I be ISO certified to apply for this tender? And then the Tenderflow model says, yes, you need to have a ISO certification, ISO 9000, 2015. So this can provide you a really nice and easy interface to work with this tender data. So I mentioned RAG, retrieval augmented generation. So this is a specific technique to include very specific data into your AI agent. And we have used this within our application to provide you with this chat interface. More about our application. We have used Vercel to host our application. So Vercel has a very nice AI kit. So it's an AI SDK that integrates LangChain, for example. And we can reuse a lot of stuff like the streaming functionality to display our answers. So we have used a TypeScript backend. So OMG, it's no Python indeed. And yeah, we were helped by the Vercel serverless functions to do so. To store metadata about our tenders, we've used also Vercel service. So yeah, we like Vercel. And we use Postgres to do that. Weaviate, so for the ones who is familiar with RAG, you need some kind of storage system to store your documents. So specifically for it's the documents about these tenders. We use Weaviate. Yeah, we use OpenAI for our foundation models, and we have LangChain as the integration tool. So more about RAG. So retrieval augmented generation. So the idea was that we used the TenderNet website and the TenderNet API to fetch all of this information. So we scrape the website and we call their API. We parse it. So you need to have this in some kind of string format, do something with it, and we chunk it into smaller parts. After that, we vectorize these string formats using an embedding, and we store those in the Weaviate database. So later I will go into specific details of this, but this is the ingestion part of our application. And now inference. So what happened when I just entered my query in the demo is that I start with my query, and this query is in normal text. But in order to make sure that I have the relevant documents to answer this query, I need to embed my query and compare this embedding against the embedding that I've stored in my database from the ingestion pipeline. So this database will provide me with a context. So you saw maybe 30 documents in this tender, and this context is a subset of these documents that help me answer our query. So we've designed a prompt that includes this context. This includes the original user query, and we ask an LLM to answer this. Just this is like I think it's a vanilla RAG inference step, but RAG is hard. So indeed, we started with this setup, and along the way we saw a lot of problems with this. So I think in a lot of tutorials it's really easy, and you can start really fast, but then doing it is hard. So I want to guide you through our journey, tell you about what we have faced, and maybe have a little discussion on how you would solve it. But the first challenge I want to discuss is parsing. So I think most of you know that garbage in is garbage out, and tender documents are very harsh to work with. So they contain images, they contain tables, and they contain table as an image. So it was really difficult for us to retrieve this kind of logic, because it's very useful to have this logic at our disposal and answer a question with it. So I think, as everyone, we started with the LangChain modules to parse our data. So we have support to do text documents, PDF documents, and Word documents. And this would just skip all of the tables and the images, and we would see a lot of problems in retrieving the correct context. So we've tried llama parse. So this is a more advanced method of parsing. It also uses LLMs to parse it, so it's a more clever way of parsing your documents. But it also includes OCR and a lot more techniques to retrieve the data from your document and put it in a format which your system can use. So an example. So if you recognize this is a picture, and it provides an overview which type of house or a type of house should be redirected to a certain government service. This is very interesting information for us. So which type of house should I focus on within this tender, for example? Llama parse would yield this. And LLM cannot do anything with it, but I also not. So it just does OCR and places it in the textual context. I've asked the LLM to say, can you give a summary of this? And it was just completely not matching this thing. So still we had a problem. After that, we've tried a complete LLM approach to parsing. So when we saw images or tables within our documents, we just ask a LLM to parse these documents and to provide us with a summary of this. And this was quite nice. So we used an image as input for our LLM, and it provided us with quite well results for the parsing method. It is rather expensive, but it did improve our performance of our RAG system greatly. So, the next challenge. So TenderFlow is available for everyone, so everyone can query your data. But user queries are often hard to interpret. So users are no prompt engineers, obviously. And we need to do something with it because it is not used by prompt engineers. It's used by people that want to apply for this tender. So an example is that, can I register for this tender with a company that has 5 employees? So what happens is that based on this query, I will find the relevant context. And it's very hard to find the relevant context if I say I have a company with 5 employees. Can I apply for this tender? There's something about maybe company requirements, and there's maybe something about employees, but not specific this one. So what we've tried to do is take a step back and ask our AI agent to rewrite our query. So we started with, can I apply for this tender with 5 employees? And we ask an LLM to rewrite this query into, are there any specific requirements for small companies or for companies? And this is like a level of abstraction higher that is easier to answer for a RAG system. Another option we have looked into is step-back prompting. So this is dividing your task in 2 steps, where you first ask, what are the company requirements for registering for this tender? So you retrieve this from the database, and after that you provide this as an additional context with your query. And then it's easier to answer this query at the second time. So all of these things are like small tweaks you can do to improve your system, but yeah, it's hard to start. So you'll only figure this out when you're doing it. And then why is RAG hard part 3? It's quite hard to track performance. So when is your answer right and when is it wrong? So indeed, you need to hire maybe a legal assistant, or you need to have some specialist that knows their stuff. So what we have tried to do is tackling the problem of we didn't have any key value question answering pairs. So the tool is new. There are no questions and there are no answers what the question should have. So what we have tried to do, and this is a little hacky, I'm curious what you find of this, is that we generate or ask an LLM to generate this question answer pair based on the context we gave it. So based on this context, can you provide me with a question and an answer that should be answered by a RAG? So you can do a little prompt engineering on this. And the idea is that there were very interesting answers in this, but not all answers were useful for our product. So what we did, and we built a chain that also with LLMs gave critic on this question answer combinations based on context. So one agent we instruct to score this question answer pair based on relevance, one on groundness, and one on standalone. And based on the scores of these agents, we would say, rate this QA pair based on this context for a RAG system, for example. And this yielded us a really nice pair of question answers pairs that we can use for evaluation. And finally, we tried to eval our system with also a LLM-based method. So we instructed the LLM to compare 2 answers, so it generated one. And it generated one by our RAG system, and it generated one by our QA system, I call it, and score it based on relevance and things like this. And this gave us a little sense on how our tool was doing, and more specifically, if an improvement or if a new functionality within our code also improved our performance at the end. Because this was the hardest problem. We want to improve our system. We try to do something, but we don't know how that compares to our previous version. So with this method, it gave us a little support in doing so. Oh yeah, we also use Langsmith, but learnings. It was a really nice process. So together with Tim, we had many iterations on what is right, what is wrong. But from our side, we had some learnings. So the last method I presented that came a little late. So for us, make sure you can evaluate your system as soon as possible. This really helps you in going the right direction when developing the system. Do not use the standard parsers. It also took some time to find out that a part of documents were missing in our vector database, and yet we had to do something about this. If we had more time, I think we would check out the new late chunking approach. So this first embeds your data and then chunks it. And then I think this approach is really interesting because it combines information more logically than doing the embedding and the chunking first and then embedding later. And I think it was also published quite recently, but this would be interesting for us to look at. And lastly, reg is still hard, but it was fun to work on. This brings me to the end. Thanks for sitting me out. And if you have questions, go ahead.